Quarterly Film Report number 26 covers progress during the period October-November-December 1965 and is the first to cover only the Saturn 1B program. Previous reports included the now completed Saturn 1 program. Saturn 1B, the second of three generations of Saturn-class rockets, is being developed for manned space exploration under the direction of NASA's Marshall Space Flight Center. The vehicle consists of two stages and an instrument unit. It will have the capability of placing manned spacecraft or large scientific payloads weighing about 40,000 pounds in Earth orbit. The first stage, S1B, is an uprated, refined, and lighter version of the S1 stage, the first stage for the completely successful Saturn 1 vehicle. The Chrysler Corporation is the prime contractor for the Saturn 1B first stage. The second stage of Saturn 1B, called S4B, is a larger, more powerful, and refined version of the Saturn 1 S4 stage. S4B will also be used as the third stage of the Saturn V. The Douglas Aircraft Company is the prime contractor for S4B. The instrument unit contains improved versions of the guidance, control, and telemetry subsystems proved in the Saturn 1. This same design will be used for Saturn V. IBM is the prime contractor for these instrument units. The launch of a Saturn 1B, which will be unmanned, is scheduled for next quarter. Manned flights will follow after several unmanned flights have proven vehicle integrity. Saturn 1B missions represent an important step in advancing launch vehicle and spacecraft technology, providing the necessary technology leading to Apollo, Saturn V, and manned exploration of space, including lunar landings. At Cape Kennedy, pre-flight checks of S1B1 started last quarter, continued through this report period. S4B was stacked atop the first stage October 1st, following pre-erection checks. SIU-201 arrived at the Cape aboard the Palaemon. Following pre-erection checks, the instrument unit was stacked atop the second stage October 25th. Vehicle pre-flight checkout began immediately and continued throughout the quarter. The Apollo command module arrived at the Cape October 25th. 2 days later, the service module was delivered. Following extensive testing, including static firing of the service module, both units were erected December 26th. Also at the Cape, installation of the final items of electrical support equipment was completed. The launch escape system will be installed atop the Apollo spacecraft early next quarter. Following completion at Marshall's System Development Facility, the S4B launch computer program tapes were delivered to KSC December 15th, concluding the Saturn 1B computer program tape deliveries for Saturn 201 automatic checkout and launch. S1B2 post-static checkout began October 4th at Chrysler Michoud and was completed in mid-November. Following completion of preparations for shipment, the stage will remain at Michoud until scheduled shipment to the Cape late January. At MSFC, S1B3 underwent two successful static firings, the first on October 12th, the second on October 26th. The stage was shipped from Marshall to Michoud November 4th. Post-static modifications and repair continued throughout the quarter. Stage checkout is scheduled for mid-January. Also, at Chrysler Michoud, S1B4 pre-static checkout began October 6th and was completed November 8th. Preparations for stage shipment started immediately. It departed Michoud December 7th and was offloaded at Marshall December 13th. Static testing is scheduled for January. S1B5 stage assembly started last quarter, was completed November 30th. Pre-static checkout got underway immediately and is scheduled for completion early next quarter. Stage fabrication for S1B6 was completed early this quarter. Tank clustering began October 22nd. Stage assembly continued throughout the quarter. S1B7 stage fabrication continued throughout the quarter. Stage fabrication for S1B8 is also underway. On November 9th at Douglas's Sacto facility, the second attempt to acceptance fire S4B202, located in Beta Stand number 3, was made. After 307 seconds of main stage burning, the firing was automatically terminated due to problems within the liquid hydrogen mass sensing system. The problem was corrected, but during countdown for the next attempt, a battery subsystem malfunctioned, terminating the countdown. On December 1st, the stage was successfully acceptance fired, indicating successful solution to all the problems encountered. Douglas's S4B-203 stage was shipped from Huntington Beach aboard the Orion October 29th. It arrived at the Sacramento River dock November 1st, was unloaded, then transported to Sacto the following day. The stage was installed in Beta Stand Number 1, recently converted from a battleship facility to an acceptance test facility. Stage refiring operations continued through the quarter, with static firing scheduled for next quarter. The S-4B battleship stage, which was removed from Beta Test Stand Number 1 last quarter, will be delivered in January to the Arnold Engineering Center at Tullahoma, Tennessee, for altitude simulation firing tests. S-4B-204 systems in-plant checkout was completed December 17th. Modifications and preparations for shipment are underway. Following final inspection, the stage is scheduled for shipment to Sacto early next quarter. S-4B-205 installation of stage insulation, begun last quarter, was completed at the end of October. Mating of the LH2 and LOX tanks for S-4B-206 was completed in October. Installation of tank insulation began in November and is scheduled for completion in mid-January. Following bonding of the common bulkhead for S-4B-207 last quarter, the LOX tank and forward LH2 dome were shipped from Santa Monica to Huntington Beach in mid-October for mating. Due to defective welds in the original aft LOX dome for S-4B-208, Douglas is fabricating a new aft dome for the stage. No shipping delay is anticipated for the LOX tank to Huntington Beach. The common bulkhead is complete and awaiting the aft dome for a LOX tank assembly. Structural testing of SIU 200-500S2, produced by North American, got underway at Marshall in late December. Testing of the unit to verify the structural integrity of the fourth and subsequent flight units will continue during the next quarter. At IBM Huntsville, SIU 202 assembly, started last quarter, was completed in mid-December. Checkout began immediately, with completion planned for early February. Also at IBM, SIU 203 component installation continued through the quarter. Completion of assembly is planned for the middle of next quarter. Fabrication assembly for SIU 204 was completed in December. Component installation is planned to start next quarter. At Rocketdyne Santa Susana facility, J2 qualification testing implemented to man-rate the engine was completed December 17th. The engine was fired 30 times for a total of 3,750 seconds. Radio interference tests, a segment of the qualification test program, were conducted at Rocketdyne Santa Monica facility. Purpose of the tests is to show that the engine will neither emit nor be susceptible to undesirable interference. Rocketdyne's research and development program on J2 engine thermal insulation is now complete. A laboratory sample was subjected to various degrees of temperature using a plasma gun to generate heat. 2 J2 engines were delivered in December, one for the S-4B-206 at Douglas and the other for the S-4B battleship stage at Marshall. Zero-gravity drop tests are being conducted at Marshall's recently completed 400-foot drop tower facility. These tests are a segment of a broad research program to determine the behavior of liquid hydrogen during orbital flight. These data will increase the confidence level of a successful restart of the S-4B engine necessary for manned lunar missions. This is a low-gravity test package in process of being released from the 366-foot level for a free-fall drop time of approximately 4 seconds. Fuel behavior data gathered during these tests will establish a baseline needed for preparation of SA-203 flight. The second stage of SA-203 will carry approximately 10 tons of LH2 into low Earth orbit. During this time, studies will be made on the behavior of the fuel within the stage during its weightless condition. In summary, October, November, and December were months of continuing progress within the Saturn 1B program. Continued buildup of Saturn 1B stages and equipment, completion of J2 engine qualification testing at Santa Susana, and pre-launch checkouts at KSC of the first Saturn 1B launch vehicle.